All right, let's look at a couple examples on how to use the distance formula. The distance formula is just an equation that we can use to find the distance between 2 points on the coordinate plane. So if we've got a couple points, here's our coordinate plane like this, okay? And we got a couple points and we want to find how far they are apart. Then, if we call this one x1, y1 and this one x2, y2, and we want to know how far apart these things are, and this fancy little formula here will tell us. All right, all it is, by the way, is the Pythagorean theorem. Pythagorean theorem says a squared plus b squared equals c squared. That's like our a squared, that's like our b squared, and we've taken c squared and we squared it. So that's where it comes from, but we won't get into that. All right, so let's try a quick little problem. So here's our question. We want to find the distance between these 2 points, and we want to keep it in simplest radical form. All right, so we have negative 3, 7, and 6, 4. All right, so those are our points. Obviously, they'd be negative 3, 7 would be up here, and 6, 4 would be down here. So we got these points, something more like this. And now we could always draw a right triangle like this. That's a pretty bad right triangle. Let's try that again. Like this. Okay, so we could draw in some kind of right triangle. That's not much better, but and we could use the Pythagorean theorem. But what we want to do is use the distance formula. So let's try that out. We've got the square roots. Plug in the numbers. So we have, let's call this x1, y1 here, and call this x2, y2. So we've got 6 as our second x value, and negative 3 as our first x value. We're going to square that. Then we have the second y value, which is 4, and we're going to subtract the first y value, which is 7. Okay? And now it's just a bunch of arithmetic. So let's do our subtraction. Careful with those negatives. Easy way to make a mistake. That comes out to be a 9 because we're subtracting a negative. And 4 minus 7 comes out to be negative 3. We're going to square that. These parentheses are important because if you didn't have those parentheses, it would get a different number when we square it. So when we square the inside, we get 81, and negative 3 squared is 9. That gives us the square root of 90. All right, and there's our answer. Now, if we wanted a decimal number, we could go to our calculator and get a decimal number, but these instructions here wanted it in simplest radical form, so we look for a perfect square that goes into that, and that is 9. And we could also, another way to factor or to simplify radicals is to do the prime factorization, but in this case, it's easy. It's just to look for the largest perfect square. That's 9. We break that up. We know the square root of 9. We don't know the square root of 10. There's our answer. All right? So let's try another problem with a little twist on it here to see if we know the distance, can we find some of the points. So here's a question where we've got a point, negative 3, 7, like we just had, and some other points. And we know the y value of the point we want, and so we're looking for a length, the x value that gives us a length of 10. Now, by the way, this AB here, without a bar over it, means the length of AB. Or sometimes we just say the distance between points A and B, all right? The length of the line segment or the distance between. So let's look real quickly at a picture that we have. So we have some points up here, negative 3, 7. Now we know where that's at. Down here, we got some other point. It's over x. I don't know how far, and it's down negative 1, but we know that it has a length of 10. Well, let's start with our distance formula. D equals the square root of x2 minus x1 squared plus a y2 minus y1 squared. All right, let's plug in what we know. Our distance that we're looking at is 10, and we've got that equals the square root. We've got our x's. I don't know the second x, so we've got x minus the first x, negative 3 squared plus y2 minus y1. Okay, got that. Now, let's clean it up a little bit. We've got x plus 3 inside here. And this comes out to be negative 8 squared. All right, negative 8 squared. I think we know what that is. 64 can be positive because negative 8 times negative 8 is positive. So that is 64. And now we just got to work our way down and get to this x in here. So let's go ahead and square both sides. Get rid of that exponent there, or that radical that is. We've got 100 and x plus 3 squared plus 64. The square here just cancels out the square root, right? Let's get that 64 out of there. And we've got 36 equals x plus 3 squared. Now we got a square root, but we got to watch out here. If we square root there, when we take the square root, we got two possibilities. There's two square roots of 36 that we've got to think about, okay? One square root is positive 6. Square root of 36 is 6. So we get x plus 3 equals 6. Or we also have negative 6, because negative 6 times negative 6 is 36. In this case, we've got to take both of them, the positive and the negative square roots. All right? On this one, subtract 3 from both sides, x equals 3. Or if we subtract 3 over here, we get x equals negative 9. Two possible answers. The reason why we get two possible answers is this. We're saying that if x is over at 3, okay, that line will be 10. And let's see, my drawing is kind of off, but the idea is this. I'm out of room, that is. If I go on over here to the right, there'd be a point. Let me maybe draw another quick picture. There's another point over here that would be 10 units away, and that would be the point negative 9, negative 1. Okay, so there's 2 points, the one that I've got drawn up here and the one over here. They would both be 10 units away from this negative 3, 7, all right? So two answers, we found them, there they are. X could be negative 9, sorry, or x could be 3. And that's how we use the distance formula. Remember, it looks like a crazy formula, but it's just Pythagorean theorem. A squared plus b squared equals c squared, but we've square rooted to put it in a different form. So, there you go.